Edexcel 2020, paper 1, the microeconomics paper. Let's get right on with it and started with the section A. So it looks like we have a diagram question, 4 marks right off the bat. Let's get started. Draw a supply and demand diagram, seems quite easy, to show the incidence. Now incidence, you may know this as burden, so it's probably going to ask us about the producer, the consumer burden, but to show the incidence of a specific petrol tax on consumers and producers, like I suspected. Okay, let's have a quick read of the stimulus. Fuel duty is a tax imposed on the sale of petrol, is included in the price paid by consumers at 58 pence per litre. So 4 mark questions, so it could be 1 mark for application, so that's quite useful. But anyway, let's get right on with the diagram. Of course, a supply and demand diagram. So let's get started with supply, demand, and then how does it tax? What is a tax? A tax increases producer's cost of production. So how is it going to affect the supply curve? It's of course going to shift the supply curve inwards from S to S plus tax. So we're going to supply plus tax, and let's just label up our axes. So price obviously on our y-axis, quantity on our x-axis. And now let's label up the diagram and let's now show these incidences. So how do we show this? And there's a good bit of revision for you guys. So QE, I'm going to label that Q1. So I'm just going to label this entire thing up. PE. So the easiest way I teach in my live classes how to work this out is just think about where the government revenue is. Since of course when the government set a tax, they gain government revenue from it. And the way we work this out is, let's finish this diagram off. So I'm going to label this point now where the where basically this intersects with the first supply curve. I'm going to label this A, going to label this equilibrium point B, going to label this point C. Now, can any of you guys identify where the government revenue is now? So the government revenue is essentially just this box. All you need to remember, it is the vertical distance between the two supply curves. So this is our first supply curve, this is our second supply curve. It is the vertical distance between them. You can actually label that up and annotate that on diagrams, but that is the amount of government revenue raised. And the way we do it, so the box will be P1, B, C, A. So that is the box of government revenue. Now, how does this help us with the question and the incidence specifically? Very simply, easiest way to think about it is the top box is always consumer incidence and the bottom box is always producer. Very simply, that's how to get 4 marks on that question. I think there will be a mark for the application though. So it says that the tax is set at 58 pence per litre, and simply just work out the government revenue. What is the government revenue? Is a vertical distance between these two curves. Just label up all the boxes. The top box is incidence for consumers and the bottom box is incidence for producers, and that incidence burden, whatever you want to call it. That's very easy, 4 marks. And let's keep going. We have a multiple choice question here. It looks like it's to do with elasticities. So an indirect tax on fuel, it is increased in a market in which the PED is minus 0.1. Which of the following is the most likely effect on consumer and producer surplus? A really interesting question, basically telling us how indirect tax, so essentially it's asking us how a tax affects consumer and producer surplus. It's given us a PED, and what does this value mean? Of course, you should know between 0 and 1. Of course, this means the demand for the good is, in fact, the PED for the good is inelastic. But now, let's investigate this. Of course, we could deduce the answer, but let's actually try understand. This is what the deep understanding of the diagrams mean. And let's try to draw this out and try to understand this. So what is going to happen to producer and consumer surplus after a tax? And let's draw these supply and demand diagrams. Okay, first things first, let's start with consumer surplus since it is a bit easier. What is the definition of consumer surplus? This, if you're struggling to remember consumer and producer surplus, struggling to work it out, first thing you need to do is make sure you've internalized the definitions. You fully know what they are, you're fully able to recall them, as it helps a billion times essentially. So consumer surplus is the difference between what consumers are willing to pay and what they actually pay. So initially, the price before the tax was at P1. And if we look above our demand curve represents individuals who are willing to pay. So therefore, all these individuals along the demand curve are willing to pay a higher price than P1, since look, it's slightly higher than P1. Therefore, all these consumers all along the demand curve will be gaining a surplus, since the equilibrium price before the tax was P1. Therefore, they're paying a lower price than they expected, that they're willing to pay. Therefore, we say that is a consumer surplus. So originally, before the tax, we said this triangle here, I draw it a bit bendy, but so this triangle here is the consumer surplus. But now, after the tax, price increases from P to P2. So now what happens to that consumer surplus? The new triangle for consumer surplus is now in fact this tiny triangle. As prices increased, therefore now there's only these individuals who are gaining a surplus, rather than it used to be all these individuals who are gaining a surplus. So essentially I can draw it in. So it used to be this massive blue triangle, and now it is this smaller purple triangle. So consumer surplus is quite easy. Now let's think about the other side of things. So we know that consumer surplus is going to decrease. Now let's think about the other side of things. And of course, the other side of things is producer surplus. Now, how do you define producer surplus? Is the difference between what producers are willing to sell for and what they actually sell for. So now let's think originally, where do we show the original producer surplus? This would of course be the inverse. It would be this triangle here. And why is it this triangle here? Since these suppliers, they are willing to sell for a lower price than the equilibrium price. However, but since the equilibrium price is higher than the price they're willing to sell for, it means they're gaining a surplus. So the original triangle would in fact be this. But now, let's think about it. The price actually increased from P1 to P2, so surely that means that there's going to be more producer surplus when we have a tax, since the price is higher. But the main thing you need to remember there is how that money is allocated. Remember, a portion of the tax goes to the government, therefore the producer does not benefit entirely from the increase in price. So now let's do the same thing we did last time. Let's find out how much the government benefits. So all we need to do is add a few more labels. So we'll call this A. So now if you recall what we just answered the last question, we said this box here, so this was in fact, there's a vertical distance between the two supply curves, this was the government revenue. Therefore, what does that mean? So all that money is absorbed by the government. And remember we said, so we've already established two things. This is the consumer surplus. We now know this is the government revenue. Therefore, what is left for producers? Now this therefore means this tiny little triangle is left for producers. Therefore, producer surplus changes from this triangle essentially to now this much smaller triangle. So to answer the question, we know both producer surplus and consumer surplus is decreasing, therefore the correct answer would be D. But just to complete this diagram, so now we have consumer, we have government tax revenue, and we have producer surplus labelled up. But now we have this little triangle here that we do not have labelled up. What does that represent? And I'm sure some of you know this, but this green triangle would in fact represent the dead weight loss to society, so welfare loss to society due to the tax. Since, of course, you could think about it in this way, the socially optimum quantity could have been Q2, but now due to the tax, there's only Q1 quantity, so just dead weight loss to society. And if you label that up on a diagram, it just means that a very simple chain of analysis, a very simple tax chain of analysis, it increases produces cost of production. And why is this so useful to understand? Since such a simple question, it's such a simple diagram, you can really elevate it to that A-star level and show your examiner that depth of knowledge you have in this tiny little area. And it just means that tiny 2-3 line chain of analysis can really be extended to 5-10 lines. And that's exactly what you need to get those A stars. Let's get started with question 2. It looks like it's another diagram question, 4 marks. Let's get started with it. Draw an externalities diagram to show the likely impact of the consumption of higher education. Now first, straight away, what we're thinking, education, of course, that is going to have consumption of education. That is of course going to be a positive externality diagram, and more specifically a positive consumption externality diagram. Now you should have revised this. Now 100% for your A levels, you need to be very confident in these externality diagrams, not just recalling the diagrams like this question is testing you, but actually understanding the diagram. There's so many questions, more scripts examiners mark. People draw the externality, students draw the externality diagrams, but actually have no idea what they mean. The students who understand, who are able to incorporate that externality diagram into the chain of analysis, are the ones who score the top marks and the A-star marks. But yeah, let's get started with this diagram. So of course, I always start these diagrams with just supply and demand. So in this scenario, supply equals what? Supply equals marginal private cost, and it also equals marginal social cost. Then we have our demand curve, and demand, let me just get rid of this side. And whilst we're doing that, we might as well just label our diagram. So it's cost slash revenue on our y-axis, then quantity on our x-axis. As a quick read of the stimulus, the external benefits of higher education include increased tax revenue, faster economic growth, and market flexibility. But yeah, so we have our demand curve, and demand in this scenario equals marginal private benefit. And then we have our social curve, which is just shifting our demand curve outwards. I'll do this in red actually. And this is our marginal social benefit curve. So now we've completed the curves, and now let's add on the other annotations we need to pick up these 4 marks. First things first, let's label up our quantity. So this is, I'm going to label this QEY because this is the market equilibrium. Why do I call this the market equilibrium? Because this is where demand is equal to supply. This is where they both intersect there. And then when the red curve intersects, so your marginal social benefit curve intersects your marginal social cost curve, which is that point there, that equilibrium, what would we call this? We would call this, in fact, the social equilibrium. So I'm going to label that QSE. Well, again, why do I call it social equilibrium? As this is where your social benefit curve is equal to your marginal social cost curve. Now, so what does the discrepancy between QE and QSE show? It shows that when left to the free market, individuals only, society only consumes QE worth of education. Now that is negative. Why? Because there's more benefit to be gained from education. If we produce QSE, like we said, that is a social efficient, that's a social optimum quantity for us to consume. Therefore, this is why in positive consumption externalities, government have to intervene in the market with policies like subsidies, policies to encourage the consumption of these goods that create positive externalities. As by only consuming QE, we are leaving a potential welfare gain on the table. And how do we show that potential welfare gain? The rule is for all externality diagrams, I try to teach this to all students, you go from the market equilibrium, and of course, like I said, where supply equals demand, that is at this point here, and you go up or down following your social curve. So our social curve in this scenario is marginal social benefit. So I'd go from the market equilibrium up or down, and this in this scenario is up. Therefore, this would be your triangle of potential welfare gain in positive externalities, and let's label that up there. And that's all you need to get 4 out of 4 marks on this diagram. I would just personally, especially when doing your essay questions, I always label this up. Always label what the difference in QE and QSE represents, which I'm going to say the underconsumption, of course, in this scenario. But yeah, let's move on, as that's how to get 4 out of 4. Remember, on these externality diagrams, price is not as relevant. Therefore, you do not need to label the price axis, as does not show much in these diagrams. But let's keep going to this multiple choice question. So, on average, in the UK, a working age graduate earns approximately 10,000 more than a non-graduate. This suggests university degrees provide substantial external benefit, external cost, private benefit, or social cost. So I think first things first, we can label out the cost, since of course by earning more it is a benefit. Now, is it a private benefit or is it an external benefit? And that's quite an easy distinction. It's not mentioned anything. External benefits, of course, are benefits to third party, are benefits to society. In this question, in the STEM, it has not mentioned any sort of benefit to society. It's only mentioned a private benefit, which of course is you personally earning more. Therefore, I would 100% call it a private benefit, and of course the answer would be C. Therefore, that is how to get 5 out of 5 marks on this question 2. And let's keep going to the question 3. Another 4-mark question. 3 4-mark questions in a row. So, explain, it's an explain question, 4 marks. One likely effect of reducing the number of tradable pollution permits. So, reducing the number of tradable pollution permits. Let's have a read of the STEM. The EU tradable pollution permit scheme is expected to become more affected by 2020 due to recent reductions in the number of tradable pollution permits. So the main effect of reducing the number of tradable pollution permits, of course, will lead to an increased price of these pollution permits, and we can show this on, of course, the tradable pollution permit diagram. But even besides the diagram, let's forget the diagram for a second. There's a set number of pollution permits. It's just like shoes, like for example Jordans. There's a set number of Jordans. Now, if these are made more scarce, if less are released, for example, instead of releasing 1,000, they release 10, what is going to happen to the price of these Jordans? Since they're more scarce, prices are going to be bidded up, therefore essentially the higher prices for these permits. And let's see how we show this on the tradable pollution permit diagram. So of course, this price of permits, of course pollution permits, what you're going to call it, and quantity of permits. And for those of you who have seen this diagram, it is a perfectly vertical line, and then we have a little demand curve with it. Now, of course, that means initially the price is here, which is the equilibrium price, which is P1, and this will be quantity Q1. But then, of course, like I said, the question STEM is talking about reducing the number of permits in 2020. So we'll shift the supply in of these permits from S1 to S2. Now let's have a look at the new equilibrium price, of course, with less quantity of permits. So quantity shifts in from Q1 to Q2, and that of course increases the price from P1 to P2, since of course the inverse law of demand, when there is less quantity, it means it will bid up the price. So let's start by defining pollution permits. I would say tradable pollution permits, it is a government allowance given, or a government scheme given to firms which allows them to emit a certain amount of pollution. But the main detail missed there is regarding the tradable side of things, which makes it really interesting and makes it really efficient, as it allows the market mechanism, the price mechanism, to take control. Then I'm going to comment on actually what happens. So when less supply of permits is increased the price of permits. But now this gets to the interesting side of pollution permits. So now the price of permits have now increased due to less supply. How does this affect firms? This provides firms with a monetary incentive to reduce pollution as much as possible. Why? As then they can sell off their spare pollution permits. And why do we call tradable pollution permits so efficient? As the firms whose easiest, it's cheapest, i.e. it's most efficient for them to reduce pollution, they now have an incentive to try to reduce pollution as much as possible, therefore sell off the rest of their permits. But the firms that's hardest for them to reduce their pollution, it's better for them. So they, instead of spending millions or billions on trying to reduce pollution, they can just buy these permits. It's the most efficient allocation of resources for society, as less is wasted. As if a firm that finds it extremely difficult to reduce pollution, they therefore now do not have to basically waste resources in trying to reduce pollution, as they can just buy it off the more efficient firm. And that's how to get 4 out of 4 marks on this question. With regards to the diagram, you wouldn't actually have to draw it. I was just drawing it to help you guys with understanding. Really good revision activity as well. But yeah, this looks quite detailed, but don't worry, just make sure you mention how it's efficient. The main thing about tradable pollution permits, of course, extremely efficient in reducing pollution. But let's keep going and let's go to that last 1 mark multiple choice. Let's tackle this multiple choice question. Regulation of firms that pollute is likely to be a problem because it, and there's 4 options, A, allows firms to use price signals. Now, if we are using regulation, that means we are therefore almost destroying price signals, therefore would not be A. B, creates unintended consequences. Now, as you know, regulation can create unintended consequences. Things like black markets can appear. Essentially, firms that are polluting can find alternative strategies, loopholes, you could say, through the regulation. So that definitely could be an answer, but let's go through the rest of them. C, fills information gaps for businesses. This, firstly, would not be a problem, and secondly, regulation would in fact create these information gaps, so definitely wrong. And D means lower admin costs. And as you know, with regulation, like for example, if the government was regulating, they'd have to hire regulators, there'd be lots of legislation, therefore this is all admin costs for the government and for firms, therefore it would definitely not lower admin costs, it would increase admin costs. Therefore the answer to this question, to this multiple choice question, would be B, and that is how to get 5 out of 5 marks for this question 3. And let's keep going to this question 4. Another diagram we are being shown here, so let's get started. Explain what happens to total costs as output levels greater than Z. I don't know whether that's grammatically correct, but that's 2 marks. So, of course, what does that point represent? It looks like that point is representing the MES, which is the minimum efficient scale, essentially. And once you've, to make it very simple, if you cut this down the middle, this would represent economies of scale. And what is this side representing? When output increases and costs rise, of course, that would be diseconomies of scale. So the question is asking specifically, what happens to total costs when output levels are greater than Z? So of course, any point on this average cost curve, total costs are rising. But then, greater than Z, what is happening? It means average cost is rising at a faster rate compared to if we were suffering economies of scale or experiencing economies of scale. So the way I'd word it is total costs are rising at an increasing rate. And this is an absolute classic exam question. The way I know this, just exam technique, just doing so many past papers, doing so many questions over the years, of course, and you guys can do the same by doing all the past papers for your spec. But let's keep going. So at output levels greater than Z, it looks like quite a long question here. So this looks like a good one. So at output levels greater than Z, which of the following correctly identifies what happens to cost? So it's really testing you on your cost curves here. Okay, so in my live classes every single year, close to the exams, one major topic we cover in depth are cost curves. Since they come up, they have a fairly high yield in the exams, especially paper 3, and students have massive misconceptions about them. So here I'm going to try to explain to you in a way that a student would understand, and most people find this really helpful, so make sure you lock in now and listen up. So this gives us lots of different scenarios. So at output levels greater, and that's the key word here, greater than Z, which of the following correctly identifies what happens to costs? Then it talks about average fixed costs, average variable costs, and marginal costs. So let's try now work out what is happening here. So first things first, average cost. It says it there. So AC. AC is interchangeable. It's just a shortened version of ATC. So AC essentially means average total costs. Now ATC, I'll write this down here. ATC, what builds up the ATC formula? ATC is built up, and this is again knowing your formulas, knowing your content knowledge essentially. So ATC is built up of average fixed costs plus average variable costs. Now let's take a deeper dive into this equation, and let's start with just fixed costs. So not average fixed costs, just fixed costs. What is a fixed cost? It's a cost that does not vary with output. For example, if I open a shop and the franchise for the McDonald's costs £500,000, that would be a fixed cost. As even if I sell 1 billion burgers a year, that will still be £500,000. If I sell one burger that entire year, I will still have to pay £500,000 for that franchise. But our average fixed cost is a bit different. It takes into account output. So essentially what you do is you take the fixed cost and spread it across the output. So for example, if I purchase a McDonald's franchise and this franchise cost me £500,000, that would be a fixed cost. Now, if the only thing I sell is burgers and I sell 100,000 burgers that year, that means my average fixed cost, like I said, fixed costs are spread across how many units you sell. But so what we do, we take 500,000, we divide it by 100,000 burgers I sold, which would give me 5, which therefore, this means my average fixed cost for that year is £5 per burger. So per unit I sell, my average fixed cost is £5. So now, going back to the question stem, and what does the question specifically refer to? It says at output levels greater than Z. So if the output level is greater than Z, of course, it means we are producing more than Z. Now, what did I say average fixed costs are? It's the total fixed cost spread across how many units we are selling. Therefore, if we are selling more units than Z, how is that going to change the average fixed cost than Z? Since remember, the fixed cost will always stay constant. So for example now, the McDonald's franchise, which was £500,000, is now selling 150,000 burgers instead of 100,000 burgers. This therefore means that McDonald's franchise's average fixed costs have gone down to £3.33 per burger, per unit, as they're selling more output. So for example, we now might be selling here. Thus, the main thing we can deduce from that is that average fixed cost is now falling as we are selling more units, and if we're selling more units, that fixed cost is spread across more units. Essentially, you're dividing by a bigger bottom side. I think it's called the denominator. Essentially, X is bigger, the denominator is bigger, thus the average fixed cost is smaller. So now we've established that average fixed costs are falling, therefore we can rule out C and D, as they both mention average fixed costs rising. But now let's work out the rest of the equation. So the first thing I mentioned was AC and ATC are the same thing, they're just interchangeable words. And if we look at output levels greater than Z, what is happening to average costs? Of course, we are going through diseconomies of scale, therefore average costs are rising. So we can say ATC is overall rising. Therefore, for this to make mathematical sense, if average fixed costs are falling, but overall the equation is rising, what must be happening to average variable costs? And of course, that must mean average variable costs are rising, thus meaning now, let's have a look at this equation. Average variable costs, there's fall and rises, so therefore this means B would be correct. So now we've worked out average fixed costs, average variable costs. With regards to MC, if you just imagine the curve there, of course it would intersect at the lowest point. I keep missing the lowest point, but yeah, of course we know that MC does rise, especially when the firm is suffering diseconomies of scale. Therefore the answer there would be, and let's keep going, I hope that explanation using the formula, just thinking about the small things that AC is equal to ATC, and then thinking about what's happening here, being comfortable with that formula can really pay dividends and will be helpful for your exam. Calculate the total costs per day, assuming it produces 400 units per day. So total cost, but let's have a read of the stimulus. For a luxury donut producer, the average selling price is £2. The average variable cost is 40% of the selling price, and its fixed cost per day is £300. So let's just work this out chronologically. So it's told us that the average selling price is £2, and the variable cost is 40% of the average variable cost is 40% of the selling price. So therefore, essentially, we are working out 40% of £2, which of course, thankfully, I would not need a calculator for, is 80 pence. And let's keep going. And its fixed cost per day is £300. So we have, this is average variable cost, And so now the fixed cost, which is just an absolute value, this is not average fixed cost, it's just total fixed cost, is £300. So calculate the total cost per day, assuming it produces 400 donuts per day. So next thing I'm going to do is work out my variable cost per day. And how would I work that out? I would take my average variable cost and times it by my quantity. The way I would do that is essentially just take 80 pence and times it by the 400 donuts they are selling each day, which will give me, which I probably will need a calculator for unfortunately, which will give me £320 worth of variable costs a day. Therefore, how do we work out total costs? Of course, it is fixed cost plus variable cost, meaning it's 320 plus 300. We'll not need the calculator for this, which will give me £620, which is the total cost per day of producing 400 units of donuts. And that is question 4 done. Had to get 5 out of 5 marks there, and let's keep going. It looks like it's a question about business objectives. So explain one likely reason why this business has remained small. So essentially, why businesses grow versus why businesses remain small. Very niche part of the spec, but it looks like there's a good question here. So let's have a read of the stimulus, and great shout out to Yorkshire there. But Betty's is a luxury cafe opened in Harrogate in 1919, specialising in afternoon tea service. Since then, it has opened a further 5 branches in Yorkshire, and it has no plans to increase the number of cafes. The 6 branches have 2 million customers per year. And like I mentioned previously, my answer here is going to be to do with business objectives. It is of course due to the owner's objectives. The business objectives as it relates to in the spec, which is point 3.2.1. It's quite funny, I just know spec points off by heart now. But yeah, so what I'm going to say is essentially just mention the spec point 3.2.1 of profit satisficing, that the owners may just want to cover their costs, satisfy the shareholders, probably what we've mentioned shareholders here, but cover their costs, and they're not hyper focused on expanding, profit maximizing to become like this large conglomerate. They just want to basically live a nice simple life, run their firm, make enough profit to cover their costs and keep going. And essentially I've just explained the concept of profit satisficing, and where they make enough to cover their costs, not focus on hyper expanding / profit maximizing. And then I've just backed it up a bit about the stimulus, where it essentially says they have no plans, they have no interest in increasing the number of cafes. So that's how to get 2 marks there, and let's keep going. Explain why the previous expansion of this business could be described as organic growth. So organic growth, very small part of the spec. It's in 3.1.2, and just a tiny part, one of the bullet points there. Organic growth essentially refers to when a firm expands not using money from like a takeover, from a merger. And of course, in the stimulus, I believe, yeah, it does mention that these 6 branches have 2 million customers. So that, of course, would have driven profits, that would have driven revenue. Therefore, I would pretty much say the previous expansion of this business could be described as organic. As had 2 million customers, they would probably have used that revenue, that profits they gained from those 2 million customers, to then use that to expand into new branches, instead of needing a merger or a takeover to fund that. So using profits / revenue from the 2 million customers to fund new branches, rather than needing a merger, takeover, for example. And let's finish off this section here actually with this 1 mark question. Assume Betty merges with a major tea leaf supplier. Which of the following, and it looks like the same spec point 3.1.2 is referring to here, so which of the following is the most likely to be an advantage as a result of this merger? Now the first thing you need to try identify is what type of integration is this, and like I said, all to do with the spec point 3.1.2. Is it vertical? Is it horizontal? Is it conglomerate? Is it even organic growth? And of course this would be vertical integration, and specifically this will be backwards vertical integration. Why is that? Of course, since they're taking control of the supply chain, and 1 step backwards, since of course these guys are the coffee makers, and 1 step backwards is controlling the tea supply. And of course, if you look at these options, so A, external economies of scale will increase efficiency. That sounds okay, but let's look at B. So greater control to lower the prices of tea. That sounds a bit more correct. Why? Since of course they are taking control of a major tea leaf supplier, therefore they will have 100% have more control over the price of tea. Industrial diversification increases risks. That would probably not be an advantage, so therefore I would say it's not C. And then D, lower monopoly power in the cafe market. By controlling the supplier, you'd say they have higher monopoly power, therefore that would also not be correct. And with regards to external economies of scale, it is more to the size of the industry. So for example, when Silicon Valley grew, of course, Microsoft, HP, they benefited massively from lower cost of engineers, since the size of the entire industry grew, if you think about the dot-com bubble. But yeah, it would not be A, therefore the answer will be B, greater control of lower price of tea. The main thing I'll take away from this one, especially if you got it wrong, make sure it's very niche, very small part of the spec, but make sure you revise these easy marks as just content test. Try and think of your section A as your bank, where if you put the work in before the exam, you can 100% score. On a bad day, drop 1 or 2 marks, score 23, 24, and on good days, on like a normal day, you're scoring 25 out of 25. Since if your content knowledge is up to scratch, you've prepared enough, you've worked out the exam technique, for example, for the 4-mark questions, where the application marks are, you should 100%. This should be your bank. You should almost walk into your exam with the confidence, knowing that if you've done all 10 of the section A's in previous years, and you're averaging 23, 24 on them, you should walk into the exam feeling confident, knowing that, yeah, that's 25 marks, pretty much bagged, and I just need to work on the rest of the paper.